Good morning. Well, I think that you yesterday had a rest and today we need to continue. But don't worry that we won't have extra work. It's just that I needed to prepare some materials to continue with magnets. So if you want to follow me with the book, if you want to read it, you should go to pages, let's see, pages 88 and pages 89. You can read through it, you can listen to the talking book, and then when you finish, you can do exercises simply learning. Exercise 2, exercise 3, and then check your learning exercise 6. Okay? So we are going to continue. What is a magnet? A magnet is an object or a material that produces a magnetic field. En Spanish, magnet sería un imán. Un imán es un objeto material que produce un campo magnético, a magnetic field. The magnetic field is invisible, but it has an amazing property that attracts metals. What type of metals? All of them? No. For example, aluminum is not here. So aluminum is not attracted by magnets. El aluminio no es atraído por los metales. But iron, hierro, steel, acero, cobalto, and nickel son los metales que son atraídos por imanes. And also magnetic field can attract or repel other magnets. There are two types of magnets, natural and artificial or produced magnets that are temporary. The natural magnets are made up of magnetite, magnetita, for example, and they are permanent. These are bar magnets, son imanes de barra, and they are permanent. And magnetite can be also a stone. But some other magnets with magnetic properties can be produced by other magnets or by electricity. In that case, they are called electromagnets, electroimanes. And sometimes these magnetic properties can be temporary. So they are only produced when we have electric current. Los electroimanes solamente funcionan con corriente eléctrica. No sé si habéis visto algún truco de magia en el cual de repente algo no se puede mover del suelo. Bueno, pues eso es un electroimán que está actuando en ese momento. Y cuando lo quitan, pues la persona puede levantar la maleta o lo que sea. Y mientras está, pues no puede. That will be an electromagnet, temporary magnets, okay? So, let's go to continue. Well, this is a bar magnet, okay? So we have here a bar magnet with two different poles. We have the North Pole and we have the South Pole, okay? And when we have a bar magnet, we can make it interact with other magnets. So we can make it repel or attract. What can we do when we have two magnets? Like we have here. Okay, so when we have the two North Poles, they are very light magnets, but when I move closer the two North Poles, well, it is not working very well. They repel each other, so they should move forward. And when we have the North and the South, they attract each other. See? They attract each other. When I put them together, they go and they attract each other. Okay? So all magnets have north and south poles. The north is represented by an N and the south by an S. And they are usually these colors, but sometimes these can be white. Okay? So, but the north is usually red. When they have different poles, they attract each other. And when we have opposite poles, different poles are opposite, they attract each other. And when we have the same poles, north and north or south and south, they repel each other. Okay? So here you have some amazing experiments with magnets. You click on the images and you can see them. Here you have 6 experiments with magnets. And here you have 27 magnetic experiments, and they are really, really cool. So I recommend that you go on the PowerPoint and you see the experiments. They are not very long videos, but they are really worth it. merecen mucho la pena, chicos, because they are amazing experiments. And we are going to do our experiments later. We are going to do some of them. So we were talking before about a magnetic field, campo magnetico. What is that? It is a region that is invisible but is around the magnet where the magnetic properties are located and is not visible. So how can we see it? Well, because we place here some iron fillings, limaduras de hierro. So these little things that you can see here around the magnet, they are iron fillings. They are little pieces of iron hierro, around the magnet. And the magnetic field has this shape. So I'm going to go to this website because it's really cool and you can see how a magnetic field works. It's a video and you can check it out. Okay, let's going to wait a little bit until it starts, if it wants. Anyway, in the meantime, I can show you the iron filling. So I'm going to show you an experiment, a little experiment. Here you have some iron fillings, okay? So I put them on a petri dish. Aquí hay algunas limaduras de hierro. And they are loose, están sueltas, como podéis ver. And now I'm going to put a magnet. I don't know if you can see it very well, but I'm going to put a magnet below them, okay? I'm going to put the magnet that I showed you before below them. And probably you can see the lines that are formed around. I don't know if you can see them very well, but lines are formed. And they are formed around them. I'm going to show you a video now, the video that I wanted to show you before. And before, I'm going to try with another magnet. Look, this is a magnet from my fridge. So I took it and I'm going to put it on top. So as you can see, also the lines of the magnetic field can be seen. If I move the iron fillings, look at them. So they are like lines that you can observe around the magnet, because the iron fillings are getting order. Here is the video from Khan Academy that shows you what is a magnetic field. A little video, it's only 1 minute, but it's really cool because you can see the structure of a magnetic field. The video is here on the right. Oh no. This is how it moves. And let me check. Is this one. Discovery of magnetic fields. Oops. I see, because I already saw it all together. Look, this is filled with iron fillings. And they place a bar magnet, and you can see now how the iron fillings go towards the magnet with a curved line. That is the magnetic field shape. Okay? It's cool, isn't it? You have the link on the presentation. They are like hair, but as I showed you, they are like little pieces of iron. When we take the magnet, they fill. So going back to the presentation, the magnetic field has this shape. This is a model, and these lines show the magnetic field. And if you notice the arrows, they go from the north pole of the magnet with a curved line to the south pole. Okay, and they are stronger here on the sides. You can see that they are closer together because here the magnetic field is stronger, and here the same thing because there are more lines. They go from north to south. And when we have two magnets, their magnetic fields interact in the following way. So when we have the north and the south, they attract each other. The magnetic field shows like this, like straight lines. This is a picture of the iron filings. When we have the same poles, north-north or south-south, they repel each other. So the magnetic field will be this way. And here we have some challenges that I want you to do, and I'm going to show you some of them. The first of one, magnetize objects. You can see here you need a magnet from your refrigerator and you need some paper clips, and you have to use the magnetized paper clip to attract another paper clip and another paper clip and another one and another one. Let's see if it works. I'm going to do it myself. So here we have the paper clips and here we have the magnet, and I'm going to take one of them. Okay, I'm going to put it here, and with it I'm going to try to get the second one. Can you see? I don't know if you notice how I took it, and then I'm going to try to get the third one, and we have a line of magnets. And these are covered with plastic, so they have no such magnetism. So try to do this at home. I'm going to try with a magnet from the fridge. And this is a cool thing. Even if I take the magnet away, the properties are temporary, but they stay for a while. So my clips now have magnetic properties until they lose them and the clips will fall. But it lasts for a while. See, this one lost it and it fall, and probably this one cannot take it again. Oh yes, it can. Look, it keeps for a while. It's cool, isn't it? So try to do it at home and show me your result. Oh, yeah, now it's not working anymore. You can go on the link and you will see a video with this same experiment to repeat it at home. And then we are going to trace the invisible magnetic field. What is to trace? To check, comprobar, probar el campo magnético invisible. So what do we need? We need a compass, una brújula. This is a compass. If we don't have one, we can use the app from the mobile phone, and they can work as well. So you can put the mobile phone, and then you are going to put the compass on the table, and you are going to take a magnet. One from the fridge will work, and you are going to put little by little the magnet close to the compass, and then you are going to check how the needle of the compass is going to switch in the distance. So you are going to see how strong the magnet is, because the stronger the magnet, the longer the distance that is going to affect the compass. And if you have a very small magnet, you have to put it very close. But with any magnet, you will notice that even if you are far away, the compass needle will move. So let's go into do this experiment. You have here the video, but I'm going to try to do it and show it to you. Well, this is a compass, as you can see. I don't know if you see it well, but the north is painted in green. Sería el norte. You can move it and the north stays in the same way. So let's see. What happens if I put a magnet close to it? Oops, I just put it on the table and it already switched. I don't know if you noticed. I'm going to do it again. And I don't know if you even know that I'm doing something, because the magnet is not on your view. I don't know. So look what happened. It turns crazy, see? But even if I am very far away, it turns crazy. I'm going to try to do it from here. So look at that. If I switch it, it twists. It's really cool, isn't it? Now, if you don't have a compass, but you have a mobile phone with a compass, you can also use it. So you have to find the compass of the mobile phone. Can you check it? This will be north. And now I'm going to use the magnet from the fridge. So let's see if it works or not. I'm going to try to put it closer. Oh, this is not working because I guess it's getting crazy. Let's see with this one. Nope. With this app, it's not working because I guess that the iPhone take the compass from the GPS, not really from a magnet that they have inside. I'm so sorry I couldn't show you the app, but if you download a new one, instead of the app from the mobile, you can download the app. It works because I did. The only problem is that I cannot do it showing to you because I am recording from my mobile phone. So, but if you download an app, if you don't have a compass, you can download it and it works with a magnet. Okay? So you can trace it here in this video as well. And let's go with two more challenges. The effect of electric current on a compass. So you can go next to a wire of a household appliance, que significa electrodoméstico, like a lamp, the hair dryer, the Nespresso, the toaster, the mobile phone charger, I forgot to put it, with your compass, and you can keep it like that. When it is off, cuando el electrodoméstico está apagado, la brújula está normal. Pero cuando lo encendemos, you turn on the household appliance, you check the compass, it will move along the wire. So you could see how the electric current is going to move the compass. This is really cool and it works. Look at this. This is like a circuit. You have here a switch and here you have a battery. Below, you don't see it. You can see the full video if you want on the link. And this is a compass. And look what happened.
When we close the switch, the current flows through the wire and the needle of the nearby compass is deflected. Again.
Lo que está diciendo es que cuando se apaga, se cierra el interruptor, es decir, se conecta la corriente empieza a pasar y la aguja, vamos a verlo otra vez, cuando la corriente pasa, se gira. ¿Por qué? Porque la electricidad, el movimiento de electrones crea un campo magnético alrededor del cable. ¿Veis? Lo he intentado hacer en casa y como tienen tan gorda la cobertura de los cables, no funciona muy bien. Entonces, si conseguís un cable finito y lo ponéis alrededor de una pila, con cuidado de que no os queméis, porque si conectamos este polo con este polo empieza a generarse corriente eléctrica y empieza a calentarse. Pero bueno, una pila tiene poca energía. Ponéis la brújula y veréis cómo se mueve también. And the last one is a glass with water and paper clips inside. So you can click here and you will see the experiment. You have to try to take the paper clips out of the glass without touching the water. So the magnet cannot touch the water either. So the question is, can magnetic fields travel through objects and different materials? So the magnetic field of this magnet, do you think that could attract the clip inside the water? Yes or not? What do you think? If you want to know, do the experiment. You can do it with a magnet and you can do this challenge to your family. Placing the paper clips here and you say, ¿qué os apostáis a que puedo sacar el clip sin mojarme las manos? And then you'll see. Okay? So the last challenge is to make a compass. So you can watch this video and you can make a compass. It's really, really cool. You just need a needle, a cork, una aguja, un corcho, un imán, and water. And then you will see how it works. And with the magnet, it switches directions. And it's really, really cool. So please try to do it. And see you next day. I hope you like it and you do some experiments with magnets. Goodbye.